morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and today we will talk about our question number eight of our interview preparation series. We all know that I am creating the remaining questions after a long period of time, but finally we are here. So pardon me for that. But now let's talk about the question. Question is, what is the significance of TCP sequence numbers and acknowledgement? Believe me, the interviewer intent from this question is to know whether you know a little bit about layer 4 or transport layer of TCP IP model or not, right? And if you know that, then you should be able to easily answer sequence number and acknowledgement, right? But as usual, we all know that my habit is to go why behind the things. It means that we need to understand completely what exactly this TCP is, and then you can understand what is the significance of sequence numbers and acknowledgement. So what we are going to learn as an answer of this question is we will be talking about meaning of connection, right? So as you all know, people say IP is connectionless, TCP is connection oriented, but what exactly is the meaning of this connection, right? Once done, then we will be in the situation of understanding sequence number, acknowledgement, and at last we will be talking about TCP handshake. Is it four-way or three-way? You all know it is three-way, but why I'm calling it four-way? You will get to know about it. We will be seeing these TCP sequence number acknowledgements on Wireshark also. At the end, we will be talking about questions. And from this question or onward of interview preparation series, what we are going to do, we will be introducing two characters, Anjali and Rahul. Naam to suna hi hoga. Basically, these are the characters which will help us to understand some of the concepts. Having said that, without wasting any time, if you want to order a coffee, if you want to get a coffee, because this video is going to be long. Okay, so let's move to our first board where we will be talking about what is the meaning of a connection.
Meaning of connection, right? So, as you all know, we have our characters Anjali and Rahul, interesting characters, now learning Wireshark with us, but they have a specific thing in mind, right? Rahul is so confused about one thing, that what is the meaning of this connection, right? We discussed IP, we didn't talk about any connection in it. We discussed UDP, we didn't discuss anything with respect to connection. What is this connection all about? Because we all know, because whenever somebody asks what is the difference between TCP and UDP, we all say TCP is connection oriented protocol, UDP is not. But what about IP? Is IP connection oriented? No, it is not. Then people ask that how can you make a service over a connection, means connection oriented service over a connectionless service? Really interesting question, but let's try to go let little bit in detail. Let's try to understand these with the real life analogies. So what's going on here right now? What we have, I have showcased you only three layers: network layer, data link layer, and physical layer. And when any network engineers see them, right, they get very happy, because this is their strongest point. Data link means switching. They are very good with respect to switching. Network layer, very good with respect to network layer. So if I talk about IP is a protocol whose duty is to send the packet from network layer of Anjali's PC or one PC to another PC, or maybe from one network to another network. What is the meaning? The meaning is it is going to take whatever is coming from the above layers, right? And suppose that layers are sending it a data, and suppose the IP address of Anjali's computer is 1.1.1.1 and Rahul computer is 2.2.2.2. What IP is going to do? IP will be taking that data and it is going to put an envelope on top of it. You all know about the envelope thing, right? It is going to write the source IP and destination IP, and then it is going to send it. And engineers like you and me have built this complete IP network, right? We have connected routers, we are running routing protocol in which we are so sure about it, right? and then we send it on these routers. Router actually do not care about what is the data. It is going to just check the destination IP address, just going to see that whether it has a route, and if it has a route, it is going to forward it. Otherwise, it is going to drop it. Right? It means that if application is sending say 500 packets, and if this router, suppose router number 1 decided to send it towards router number 2, all the 500 packets, and router number 2 is so busy means the CPU is already almost 100%, it is not able to process the new packet, then what is going to happen? Maybe some of the packet it is going to drop. If that is the case, how many packets? And suppose 100 packets means around 20% of the traffic of the packets this router has dropped. If that is the case, how many packets are going to reach here? Only 400 packets. Does IP care about it? No, absolutely not. There is nothing in Internet Protocol or IP which cares about loss of packet. No, there is nobody. Right? If we talk about on the top of UDP, means suppose there is a layer which is known as transport layer, and if I talk about we have UDP here, which we discussed in our last class, what is going to happen? This UDP is actually taking the data from application, and we discuss about the real-time data. Just you collect it and send it. There is no point of sending something which is missed again and again, right? Or again. If that is the case, then this application is going to send some data to UDP. What UDP is going to do? UDP is taking this letter from the application, it is going to put the header, 8-byte small header, and then it just sends. It doesn't think. UDP doesn't think, right? That what is going to happen if this piece is missed, if this data is lost in the transit, because at the end of the day, this UDP is going to use this network service totally. It is going to use this network service, which is IP. IP is connectionless, means nobody think about it. What network layer is going to do? Network layer is going to take this UDP data, it is going to put an envelope on top of it, and it is going to forward it on this IP network. And this, there might be chance that some of the router or maybe one router can drop some of the packet, and that is the case, it's a big problem, right? In some cases it is a big problem. In what cases it is a big problem? Suppose Anjali want to send a letter to Rahul, and there are some important information. Anjali doesn't want even one bit of this letter should not be dropped by the network. Whatever I am sending as it is, it should reach. Otherwise, there is going to be really huge problems. What problems can happen? I will be showcasing in the next board. But the idea here is simple. We need somebody. We need something which can think before sending, which can make sure that if my packet is dropped, there must be some way to resend it, right? And then what we did, we on the transport layer, we build a protocol which is known as transmission control protocol. And then you must be thinking, Mr. Vishnu, I don't think that whatever you are saying is making any sense. Irrespective of the fact that it is TCP or UDP, right? We understood UDP because it doesn't care, and it is again using a careless service which is IP, right? Which can drop the packet. So UDP doesn't care, IP doesn't care. We understand that for the real-time communication, that is fine. But if you build a protocol which is TCP also on the transport layer, what value you are adding? Because at the end of the day, you are actually using IP, Internet Protocol, which basically doesn't care about losing packet, which can drop packet. It means that there is no reliability, there is no guaranteed delivery of the packets, because TCP want them, right? But eventually, because you have built the TCP IP layer, TCP IP model, and the TCP IP model is at network at layer number 3, we have only one protocol, which is IP. But believe me guys, everything is working fine, right? It means that there is something happening before sending actual data, right? which is taking care, means we are making something extraordinary, right, which is taking care, which is absolutely giving us this sense or security that whatever you are sending using TCP, there is not a single packet that can be lost. And we are building this TCP on top of IP, which can make your packet go away, right? How even this can be possible at all, right? So on this board, if you understand the problem, that what problem we are trying to solve, right, it means that there must be something which can guide us, which can say that something is dropped in the middle. And if something is dropped in the middle, there is no point of sending the data to Rahul. And what that something is, we need to understand. Although I haven't explained you the concept of connection, but I have built some grounds to understand the meaning of connection. To understand that, let's talk about one interesting problem, right? The problem, in fact, if you have gone through my TCP course, this is the same thing which I have explained there. But believe me, most of the people doesn't understand the meaning of connection. Why exactly, the why behind it, they don't know. Let me tell you. Again, we have Anjali, we have Rahul. Mr. Rahul have already proposed Anjali, and he is waiting for the answer. Anjali is in dilemma what she should write, and she has decided that she want to say I don't love you. And she has used any application, maybe WhatsApp, maybe anything else, which is an application layer, and now she is sending this to directly network layer. I just want to showcase you that if we do not have something here which is having lots and lots of thinking capacity, that what can go wrong, what could be on the stake here, right? So Anjali is saying I don't love you, right? And then basically when it reaches to network layer, basically it is going to uh, uh, we will be having different packets, and suppose one packet is taking information I, then don't, then love, then you. What is going to happen now? Network layer is going to put some header on top of it, right? And then it is going to send, what is this header? This is going to be IP header, source IP, destination IP, and then it is going to send it over this IP network. And this IP network, maybe this router number 2 is highly congested. He let this packet to go, means I can go, love can go, you can go, but unfortunately, right, it dropped this don't packet, which is having this data don't, and then the packet reaches here. What network layer is going to do? Network layer will be sending it to application layer, right? If that is the case, what message Rahul will be getting? Rahul will be getting I love you. He's so happy now, right? But is this a correct message? No, not at all, right? We are missing something very, very crucial here. If I put a layer here, suppose the transport layer, suppose I have, and I have only one protocol, which is UDP, can it solve the problem? No, absolutely not, right? What can I do? We have to build something here itself, which is taking the application data from the application and making sure everything will reach, every single packet can reach to Rahul. And we have to build this thing so that it is eventually will be utilizing the IP network, which is a lossful network. It can, you can say the data can be lost there, can be, we can lose some data there, right? So what could be the solution of this problem? The solution of this problem is that until and unless we have all the data, we are not going to forward. But how can we make sure that we have the complete data or not? And believe me, if you throw this problem to a 10th grade student, 5th grade student, they will definitely let you know that what is going wrong here, right? Even my wife, she doesn't have any background in technology, and I throw this problem in the simple terms with to her, and she replied back, right? And it was amazing that she is saying that it's very simple problem, right? What you can do, just write down the numbers on these packets, whatever you have. For example, the first packet, you can give it's a number 1, This is my number 2, this is number 3, and this is number 4, and that is it. Your problem will be solved. And then I was thinking that how the problem is solved, and she is explaining here. See, if you can give the number to these packet, number 1, number 2, number 3, number 4, and then you send it from transport to network, right? I do not care whether some of my packet have been dropped or not. For example, on this router number 2, if this packet number 2 is dropped, suppose, that is fine. What I'm going to get? I will be getting only packet I love you. But what I'm doing exactly here is that if I do not get packet in sequence, means 1 is there, 2 is not there, 3 is there, 4 is there, I am not going to forward this packet to Mr. Rahul, because my packets are not, means all the packets have not reached, right? And you must be thinking, yeah, it's a very, very simple solution. Believe me, this is the solution which TCP guys have given, right? I will showcase you exactly this is the solution, but they have given. But now my question is, this number, the starting number could be anything, right? Maybe Anjali can decide to talk from number 5, number 6, or number 8. How Rahul will eventually understand, right, that Anjali is starting her conversation from packet number 1, right? This is interesting. So now we have to think about it, that instead of sending data directly, see what network layer was doing, taking the packet or taking the data from the application layer, transport layer, and just slapping the IP header on top of it, and then and then sending it. What UDP was doing, taking the data from the application layer, just putting the header and sending it. But now there is a need to think before sending, right? So basically, whatever the data I have, I am not going to send until and unless I tell to Rahul that, Rahul, I want to talk to you, right? And I have some data, and I will be sending that data to you from number 1, means packet number 1. Interesting. Now you must be thinking, Mr. Vishnu, it's an intelligent thing which you are doing. But at the end of the day, your packet number 1, which is having this information, it is going to go over this IP network, right? Which is a lossy network, and where this packet can be dropped. I understand that. I totally understand it. But try to think. If I tell Anjali that, Anjali, do not send data, before sending data, you just tell Rahul that I want to talk to you. Here is my packet number 1. And if you do not get any reply back, it means that you understand 2 things from it. Rahul is not there at all, right? And the second thing is that your packet, this whatever you are sending, doesn't reach at Rahul, right? If it doesn't reach at Rahul, send the packet once again. Maybe you just wait for, say, 45 seconds, or maybe you wait for just 2 seconds. And if something doesn't come back from the Rahul, you send it again. It is high chances that if you send it again, maybe the congestion is over and this packet reaches there. And if it reaches there, as soon as Rahul see the message, okay. And by the way, these are not your data, means I don't love you. You are not sending anything. Right now, you are just sending packet number 1, which says that I want to talk to you, Rahul. And here is I want to start this communication with packet number 1. And Rahul is saying, perfect. That's great, right? He is just saying, perfect. That's it. This is the packet number 1. This is the packet number 2. Interesting. Don't you think that now, and this packet, and I am thinking this packet is reached to Anjali, right? If it doesn't reach, then of course Rahul means if Rahul has received this and basically it is sending acknowledge means this perfect message, and he's not getting the communication, maybe Anjali again send the packet number one, right? Because this message is missed, because we have considered both the situation. Now try to understand, when two parties communicate, there are two data streams, and you must be thinking, Mr. Vishnu, what is the meaning of data stream? The data stream is, see, when Anjali said, I don't love you, this is the data stream which is going from here to here, right? For this, Anjali has said that I want to talk to you. Here is my packet number one. I want to communicate with packet number one. And Rahul is saying, okay. But don't you think that there must be a communication from Rahul towards Anjali, right? And this is the second stream I am talking about. This was my first stream. So there are two different streams when we communicate over any TCP or basically UDP, because one from source to destination, the other one is from destination to source. As simple as that. It means that once, because Rahul also want to send something, right, as a reply. So Rahul is also saying, Anjali, I want to talk to you, and I want that communication start with maybe packet number 5, 4, 3, 2, 1, whatever, right? And Anjali says, okay, perfect. I think these 4 messages should go before sending any data. I haven't sent any data. What I have sent, I am trying to make something between them so that Rahul can understand that Anjali wants to communicate to me and she wants to send her packet from packet number 1. Anjali understand Rahul wants to communicate to me and he wants to send from packet number 5. That's it. And one more thing which is happening. Don't you think that after these 4 messages, Anjali understand that there is somebody, there's at the remote edge, somebody is there. Because when I sent the packet number 1, he replied back with the perfect. Rahul understand that there is somebody at the remote end, because when I send when I say I want to communicate, she said yes, right? So it means that what is going on with respect to these 4 messages? Number 1, both the parties know that there is somebody at the remote end. There is no doubt about it, right? And second thing, both parties know, right, what is the starting packet number of the communication. Guys, there is, if I say these 4 messages, these doesn't contain any data, these don't contain any data, and these 4 messages actually make a connection. This is the connection. Connection doesn't mean I am stretching a wire from Anjali to Rahul. No, absolutely no. Connection means I am sending these 4 messages over this IP, which is a lossy network, right? But I want to make sure that to begin with, these 4 messages should be there. If these 4 messages are there, exchange has happened, it means that there is something which is formed between Anjali and Rahul, and we call that a connection. Connection means these 4 messages. Connection doesn't mean there is a single wire which I am stretching between to them. Try to understand this, right? But you must be thinking, Mr. Vishnu, you are teaching absolutely wrong thing to us. And when I asked why, they said, why are you sending these 4 messages? Do you want to say that we have a 4-way handshake? See, these are terms. Believe me, to begin with, if you want to start a communication, right, this is making sense to me, right? But we can improve this messages as we go on. We can reduce this from 4 to 3. We can call it a 3-way handshake. That is fine. But when we start building something, right, we are solving a very good problem here, because IP network, there is a chances of losing a packet, and on that network we are trying to build something, right, where the packet can't be loose, right? For example, in file transfer protocol, we make sure that file at the sender and file at the receiver is exactly the same, right? Otherwise, what is the purpose of file transfer? There should be no loss of any data. If that is the case, we want to use TCP. If you want to use TCP before sending data, we need to send these 4 messages, and these 4 messages are actually your connection. As simple as that, right? So guys, I think I have talked around 25 minutes. If you guys, although all the things are general, but if you guys want to add something on top of it, because I know that people have a problem understanding this word connection. I am again repeating, connection is just sending these 4 messages, right? I will prove you that we can improve this process. We can make this process efficient of sending these initial message. Instead of sending 4 messages, we can send only 3 messages and it should work fine, right? But that is just efficiency. We will include efficiency later, but now let's try to understand. As I mentioned, that sequencing the packet is important. The meaning is, Anjali is saying that I want to talk to you, right? And I will be sending you the packets from packet number 1, packet number 5 or 6 or whatever, right? So now let's see, whatever the generalized concept we just discussed, we would like to see what exactly happens when we are going to seize these packets into the Wireshark, right? So what is happening here is, we have an application, and believe me, application just give me data. For example, we have a big file here, right? It is sending me 101001 whatever corresponding, because every data can be represented in the form of ones and zeros. In like the complex video, in like the image or anything, whatever, because computer understand only ones and zeros. If that is the case, from application we are receiving this, just like means if you open a tap, the water flows, just like the bits are flowing towards transport layer, right? And what this transport layer is doing, transport layer is accumulating these packets into a bucket, maybe, right? And then it is going to chop them, means chop them meaning is it is going to create small segments. So basically the unit of data at layer 4 is, or transport layer is, your segment. For example, if you get say 500 bytes of data, suppose, right? So 500 bytes means 500 into 8 bits means 4000 bits, as simple as that. So what is going to happen here is, what we will be doing, and suppose every packet, or sorry, every segment can take 1000 bytes of 1000 bits of data, or this calculation is going to be a little bit problematic. So what I am going to do is, now that is fine, 500 into 8. So what I'm saying is, suppose I have these let me do the calculation a little bit simple so that we can understand. Yeah, suppose, let me do the simple calculation first. Suppose we accumulated only 80 bits, suppose, right, in the first thing, or maybe say 320 bits, suppose, right? So what we are doing is, we and suppose in a segment we can carry only 80 bits, suppose 80 bits, 80 bits, 80 bits. Do not worry about, I will be talking about maximum segment size, okay, and 80 bits here. So what TCP does actually it sequence, or it gives the sequence number to every byte. And you all know that 1 byte is equal to 8 bits, as simple as that. It means that if I have 8 bits in this segment number 1, segment number 2, segment number 3, segment number 4, segment number 5, right? Then what is going to happen? We have 80 bits here, 80 bits here, and what TCP is going to do? TCP will say that I have 10 bytes in segment number 1, I have 10 bytes in segment number 2, then 3, then 4 and 5. And what I am showcasing you here is, this is my one segment. Guys, these are not segments. This is the total segment, whatever I have represented here. So application is giving me in the form of ones and zero, right? And that what I'm doing is, I am dividing, or I am dividing them into multiple segments, and every segment is going to have bits, you know that. But TCP is not going to count the bit, it is going to count the bytes. For example, if this segment number 1 is having 80 bits, it means that it is going to have 10 bytes. As simple as that, right? So what I'm going to do, I have accumulated 8 bits here, means byte number 1, byte number 2, byte number 3, and then TCP is going to give a sequence number to every byte. This is very, very interesting. And the number of first byte is known as the sequence number. Really simple. Now, so this was my first, let me delete all these things. And now what is going on? This is my sequence number 1. And in the sequence number 1, how much data I have? I have 10 bytes of data inside it, right? How many bytes? 10 bytes. And basically this 10 byte is known as the length of data. Very, very interesting. Sequence number is the first byte, and what we have here we have 10 bytes. It means that we have 80 bytes of data in this packet. Now just try to understand where people get confused. This is my segment number 1. Similarly, I am going to have another segment which is again going to have, say, I'm just saying, taking the size as same, right? So which is going to have byte number 11, then 12, then 13, then 14, then 15, then 16, then 17, then 18, right? And what I'm going to do, I am going to sequence them with the sequence number. Means this is my sequence number 11, this is 12, this is 13, this is 14, this is 15, 16, 17, 18, right? Now the question is, can I know, this is my segment number 1 and this is my segment number 2, right? From sequence number 1 and packet length, can I know what is going to be the sequence number of next packet or segment? I just get a little bit confused about segment or packet, so please pardon me. If I'm talking about segment, it is going to be the transport layer. If I'm talking about packet, it is actually the network layer. So I get confused. So right now, try to understand the emotions here. If I say packet, it is segment, because we are talking about a segment. So if you take a sequence number, which is 1, and if you add length into it, which is 10, and if you add them, whatever the number you are going to get, it is the number of your next sequence, or the sequence number of next packet or segment. As simple as that, right? But you must be thinking, Mr. Vishnu, why are you teaching this first grade or second grade mathematics to us? Believe me, when I showcase all these things in Wireshark, people get confused. Why? Because see, there you are not going to get these numbers. The numbers are going to be big. For example, you can get that the sequence number of this segment is, suppose, say 215, and then the length of this segment is, suppose, 100. Then if I ask you what should be the, and this is my packet number or segment number, say 7, and if I ask you what is the segment number 8 sequence number, it is going to be very, very simple, because 215 is the first byte of this packet, right? And the last byte is going to be, the next sequence number is going to be 215 plus 100, means 315. That is it. So if you know the length of the data, whatever the actual length of data, and if you know the sequence number, then you can easily calculate the sequence number of the next segment, which is going to be the first sequence number of the first byte. As simple as that, right? Maybe means the simple topic I have explained you in a little bit complicated way, but I'm so sorry for this. If you have any doubt, any question, please do ask me. But if you can take any segment, what TCP is going to do, TCP will see in the data there are going to be bits. It is going to say no, I will not sequence every bit, I will sequence every byte. So it will convert them into the byte. Every byte it is going to give you the sequence number, and the sequence number field is, that is why it is big. It is 32 bit long, 2 to the power 32. It means that we do not have shortage of numbers, so do not worry about it. You can see very huge number in the Wireshark. But if you know addition, definitely you know addition, right? Means if you add sequence number plus length, it is going to give you the sequence number of next packet, because the packet sequence number is the sequence number of its first byte. As simple as that, right? Guys, if you came across any doubt, please let me know. Now I am going to tell you the concept of acknowledgement, which is very, very important. Now I am not talking about the initial connection, because Anjali and Rahul has made that connection. Yeah, so I request you to please just raise your hand. It is going to be really, really nice. But yeah, please go ahead. So what is happening here is, if see again, I am saying we have an application. Application has given us say 160 bits, suppose, right? And in my one segment, maximum I can carry suppose 80 bits. This is my segment number 1. Then I will be having how many segments? I will be having 2 segments, 80 bits and 80 bits. This data I need to send, right? If that is the case, what is going to happen? Now TCP wants to give the sequence number, but it is not going to give the sequence number to every bit. What it is going to do? It is going to say I will divide 80 bits into bytes. 80 bits into byte means 1, 2, 3, 4, 5, 6, 7, 8, right? So it is going to say this is my first byte, this is second byte, third, fourth, 5, 6, 7, 8. And suppose the sequence number is starting from 1. So first byte it is going to give you sequence number 1. But this is my one segment. Okay. This is my second segment. And of course, this is the first, and the last one is going to be the 10th. So if you add 1 plus 10, it is going to give you 11. It means that the next segment, whatever it is, and if you divide it, then it should be having some sequence number. This sequence number should start from sequence number 11. Is it fine? Oh yeah, again that I understand your question. Just give me 2 minutes to explain, and then basically this is what. So what exactly happens, and this is also the question asked in the Hindi class. Thank you so much, Syed. What exactly happens, how basically it is going to be divided. So you all know that we have this transport layer, we have then this network layer, and then we have this data link layer. And if I'm talking about a client, suppose this is my client. So this network interface card of this client, most of the time this is Ethernet, and it says that I cannot take data more than 1500. So the data link layers say whatever I am going to get from top, it should not be more than 1500 bytes. Okay, Mr. Sayed, but how it is going to change the things according to us? Now we are having an application on top of which is sending the data, right? And now transport layer knows that at data link layer, this data should not be more than 1500. So what intelligent thing it is doing? Whatever the application is sending, suppose it is sending so much of data, it is taking first segment. It is going to say that I will be taking only 1460 bytes of data. If you are getting confused with it, do not be, because on this 1460 byte of data, there are 20 bytes of header which this transport layer will add, right? Which is known as TCP header, which we are talking about. And then this will be given to network layer. What network layer is going to do? Network layer will be taking this 1460 byte plus 20 bytes, and it is going to add its own header which is 20. Now just add them, 1460 plus 20 plus 20, it is going to be 1500. Now Ethernet will say perfect, right? So see the vision of transport layer. Transport layer is checking from operating system that basically my data link layer cannot take more than 1500 bytes of data. I'm talking about data because it is going to add some header data link also. But data link layer is saying I cannot take more than 1500 bytes of data. It means that network layer eventually will give it only 1500, and this is known as whatever at the transport layer, whatever we came across this 1460, this is known as maximum segment size, right? So it can be less, but this is the maximum. If we have more than that, then basically data link layer has to do some work. It needs to fragment the packet, right? Am I able to explain myself, Syed? Syed ji? Perfect. Now, Mr. Nataraj, please unmute yourself and ask your question. Please go ahead. See, that is the property of this your data link, right? Means switch to switch communication. Basically, you enable jumbo frame on this switch. You enable jumbo frames here only. But overall, it assumes that basically most of the time the packet is generated by the end host, means the server or the client, right? Although now this 1500 restriction is open, means some servers are capable of sending, for example, if you see the data centers and server to server communication, when the when virtual machines are copying right over this server in the data center in east-west traffic flow, then basically this restriction means some packets can be 9000 bytes also. But mostly if the end host is generating, then basically we have a restriction of this 1500 packet. But now you can say that when we send packet between these switches, this thing can be 1500 and something else, right? So we enable jumbo frame concept here. But overall from the transport layer, it is going to be 1560. Whatever is happening, it is happening at the data link layer at the switch, and host doesn't care about it, right? But your question is good in terms of that. For example, if you have a router in the middle, right? And we have router number 1, router number 2, router number 3, and then basically end hosts are connected. End host is here A, end host is here B, right? Now basically these end hosts, if we do not have any mechanism, it is going to say maximum segment size is 1460, which is basically which happens in the handshake itself, that this machine is going to say that my is 1460, this is going to say mine is 1460, right? But problem is if this R2 is cannot send more than 1300 bytes of on this interface, then basically we are having the problem, right? And then this is the responsibility of internet protocol to fragment this packet. And if the fragment bit is if the fragmentation bit is set, means you can fragment the packet, then basically this 1500 byte packet can be fragmented into two. One is 1300 and the other one is 200 or whatever, right? And this is the responsibility of routers to reassemble it before sending it to this. So if we want to remove this fragmentation in the middle, then basically there is another I think I'm forgetting the name, but through the ping packet basically basically we can send different ping size packet and to check whether packet fragmentation is happening or not, and then we conclude on the smallest maximum segment size. So those are the things which we can do. But again, whatever is there which is coming into your mind, I have explained each and everything in this TCP course. Just go through it. But questions are nice. Anybody else? Mr. Vipul. No. I'm talking about layer 3. I'm talking about layer 3. So because at the end of the day, see, there are in the data center, there are two types of traffic. And one of them, which is very, very heavy nowadays, is that if we have 2 or 3 servers, right? then these servers are communicating with each other. Maybe if virtual machine is failing here, then it is copied from here to here, and this requirement is huge. Previously the requirement was from traffic between north and south, but nowadays it's a huge requirement in the world of AI also, that these servers are communicating amongst each other. Now I'm taking that these servers NIC, right? If we talk about our laptop, this can carry only 1500 bytes of data, right? But now these servers are capable of generating a huge packets, right? And now the maximum segment size here can be 9000 here. Means if we are talking in data center, and that is why basically if you have this switches, intermediate switches, you have to enable this what we call the maximum segment size on this switch is 9000, right? Configuring MSS and all. Yeah. Now, yeah, no worries, no problem. Mr. Tapan Saha, please ask your question, Mr. Tapan. So basically, data is coming from the top, Tapanji, right? So this transport layer, because everything is implemented in the operating system, transport layer can see that what NIC it is connected to, and what is the maximum transmission unit of this NIC, which it will come to know as 1500. Now it is the responsibility of transport layer, because it knows that I am going to add 20 bytes of data as a header. Then network layer is going to 20 bytes. Then I do not have any option, and means basically I should be creating the segment of, means the maximum segment size should be 1460. It can be lesser than that, but I cannot create more than that, Tapanji. There is lots and lots of data from the application, but those are going to be many segments of 1460 then, right? And these many segments, that is what we are going to send. First segment, second segment, and then we are still we are in the middle of this TCP communication. But thank you so much for your lovely question. Let me complete it, and most of your doubt will be complete. Will be gone, right? So now what we have done till this point, we have just taken data from application, and then basically we have multiple segment, but inside those segment, whatever the bits we have, right, we have converted them into byte, and we are giving one sequence number to one byte, as simple as that. Now we are talking about concept of acknowledgement. So what has happened before that? Now I have sent, suppose I have Anjali and Rahul suppose has a connection. Connection means that four things have already happened. First thing first, where Anjali is saying, here is my, I want to talk to you, and here is my initial sequence number, right? She can say that, and basically we call this as a SYN message. Why SYN message? Because Anjali want to synchronize with Rahul. Anjali want to make a connection with Rahul, that Rahul, this is my synchronous message. I would like to tell you that I will be sending the messages from sequence number 1, and then Rahul will say, that's great. That's great means he is acknowledging this thing. So this is my packet number 1, this is my packet number 2. Now this was the communication from Anjali to Rahul. Now Rahul want to say, Anjali, if you want to talk to me, I also want to talk to you, and I will be sending my message from maybe packet number 5 or maybe packet number 1. This can be 1 also, right? And then this is going to be my packet number 3, again SYN message, and then Anjali is going to say, that's fine, acknowledgement. So basically, once we have these 4 messages which I was discussing, it means that there is an initial bonding, there is an initial connection between Anjali and Rahul. Now suppose after this, Anjali is so sure about that Rahul is there, Rahul is so sure about that Anjali is there, because they have sent SYN-ACK messages, right? Pardon me if you are again getting that Vishnu is teaching us again wrong. These are not 4 messages, Vishnu, these are 3. I will make them efficient, don't worry, right? So now, after this connection, Anjali want to send a data, right? So Anjali is saying, here is my data, as I promised that I will be sending data with this sequence number 1, and which is having a length of 100. Now what should come into your mind when you see this? You will see that Anjali just received some data from application, and what she has done, she has she has made 100, basically 100 bytes into them, because the length is 100. It means 100 bytes. It means that every byte she has to sequence, right? And the first byte she has given number as sequence number 1. This will be 2, this will be 3, this will be 4, this will be 5. What should be the end one? This is going to be the 100th one. As simple as that. She has started from sequence number 1, and because the length of this segment is 100, it means that the last sequence number is going to be 100. As simple as that, right? Now, when Rahul received that, Rahul is going to say, okay, I have received your sequence number 1. Because it is having length 100, I have received till sequence number 100. It means that I have received 100 bytes from you. And now I am expecting a packet which, or the segment which starts with 101. He is going to say acknowledgement 101. What is the meaning of acknowledgement 101? The meaning of acknowledgement 101 is that I have received data till 100 bytes, and I am expecting you another segment. If you have any, please send me, but make sure that it is starting from 101. And Anjali is saying yes. And when Anjali received 101, Anjali knows that her packet with sequence number, or her segment with sequence number 1, just received by Rahul. And she also know that the sequence number 1 has length of 100, means the next packet I am going to send, the sequence number is going to be sequence 101. How the calculation is coming? It's very simple. Add 1 to length, which is going to be 100, means 101. 101 is going to be your sequence of next packet, and this is the 101, and the length is 200. Now, once this packet comes to your mind, you should be thinking like this, that Anjali has a segment in which there are 200 bytes. It means that these are 200 little rooms, right? Anjali will be marking this as sequence number 101 for the first one, and this is going to be the sequence number of this entire segment. Guys, these are not 200 segments. There is 200 bytes of data in this segment. This is just the second segment. This is my first segment, right? So what is going to be the end packet number? So the sequence number is going to be from sequence number 101 to 200, right? And basically the length will be your 200. So when this thing comes to your mind, you think about this. And what Rahul is going to do? Rahul is going to do, I have received now 101 to 300. Oh, so sorry for that. This is not, because if it's 200, then it is going to equal to 300. So sorry for this. So Rahul is going to say that from 101 to 300, it has received the data, and it is asking from 301. As simple as that, right? So this was the concept of acknowledgement. Now let's talk about handshake. And again, I'm going to showcase you handshake in the 4-way manner, but believe me, it is 3-way handshake. We will optimize it, right? But try to understand. If you get this, then basically on Wireshark you can easily understand most of the things, right? Now we are talking about now the initial connection. The first thing first, before it, I would like to tell you one important concept, and this important concept is known as flag, right? It's very, very simple, guys. You have seen so many cases. I give it with an interesting example, that suppose I am in a restaurant, right? And there was one restaurant, very good restaurant. I am sitting on this table and I am enjoying my food. And basically this restaurant is having this flag, right? And the flag means that if it is up, the meaning is I am still hungry for the starters. So whoever the waiter is, if he sees that this flag is up, he will continue serving on my table the important, what we call important starters, right? And I'm eating and eating, and then after 1 hour, maybe 25 minutes, I'm done. Then what I'm going to do, I will stop I will uh, just drop this flag, right? If that is the case, then this waiter will see that no, the flag is not standing, not in standing position. It means that this guy is done. So this is the maybe small protocol of this restaurant, that if the flag is up, I'm going to continue serving on this table, otherwise not. It means that the flag is indicating me something, right? For example, if I talk about TCP header now, you should know that in TCP header, there must be something known as sequence number. And what is the meaning of sequence number? Whatever the segment I have, the first byte of this is having some sequence number, right? And this is going to be the sequence number of this entire segment. As I mentioned, this is of 32-bit. And then I am going to have acknowledgement number also. What is the meaning of acknowledgement number? Acknowledgement number means if I say that I am sending you a message with acknowledgement number 501, it means that I have received data till 500 bytes. I want a message or a segment with sequence number 501. As simple as that. This is also a 32-bit number. But in TCP header, there are some 1-bit field which indicates something, only 1 bit, right? So this flag has 2 position only, if it is standing or maybe it is down, right? Similarly, this flag can be 2 values, 1 and 0s. So if this flag is having 1, means continue serving me. If it is 0, stop serving me. So 1 means flag is set and it is specifying something. 0 means flag is not set. So you are going to see these things in Wireshark, right? So now, what is happening here? Anjali want to send that the same thing, I do not love you, but she knows, right, that the protocol on which this data is going to go is IP, and this don't can be lost there. So I am not going to send it over UDP or IP. I will take the protocol which is the reliable protocol, which is going to send the complete message, so that Rahul is not an illusion. So TCP is her choice, although TCP is again going to send the data over the same IP, but with some improvement, with some logic, with some thinking. And that thinking I am explaining you, that Anjali is saying, here is my first message, and it is starting from sequence number 0, right? And length is 0 because I am not sending data at all, because I do not want to send data until unless I am absolutely sure Rahul is there, until unless I am absolutely sure that Rahul understands that I want to send it from a specific sequence number. And Anjali is saying that this is my synchronous message by setting a flag sin is equal to 1, so that when Rahul sees this, he understands this is not the data message. There is nothing called data in it. This is just the synchronous message. Anjali want to talk to me. She has sent a message with sequence number 0, length 0. Now, Rahul is saying that I acknowledge it. Anjali, whatever you have sent, I acknowledge it. He is saying acknowledgement 1. He is saying that now I expect you to create a message. The next message or the data which you want to send me, just send me with 1, sequence number 1, because acknowledgement 1 means that 0th message has been received, and now I am expecting message from acknowledgement number 1 or a message with sequence number 1. Now you can argue with me, Mr. Vishnu. Don't you think that you have made a mistake? Then I would ask why. You just said that if you add sequence number and length, then it is going to give me the next sequence number of the segment, right? But here sequence number is 0, length is also 0, and it is going to give me the 0, then 0 is the next segment, and this is the problem, right? Everybody says that basically we are starting the communication here, right? So there is something called a ghost byte. Leave that ghost byte. Try to understand the logic. What I'm saying here is that Anjali has a TCP here, Rahul has a TCP here. See why we are exchanging all these messages to begin with. We want to be absolutely sure, Rahul want to be absolutely sure, Rahul's TCP want to be absolutely sure that Anjali will be sending me message with some sequence number, and I would like to know that sequence number, right? That is why Anjali is sending the synchronizing message. So TCP at Rahul and TCP, because both have written by single one, single organization, single guy, right? And they are guys like us. They understood all the things which we have discussed in the normal life, and they are saying that okay, this is the normal setting between us, that if Anjali is sending with the sequence number 0, length 0, it means that we have received it, right? And now I would say that we are going to expect the next sequence from 1, and this is what I wanted. Now Rahul knows that whatever Anjali is going to send as in data, it is going to be from sequence number 1. That is the problem we wanted to solve, right? Understand that means we are marking our packet from 1, 2, 3, 4, and we wanted to info Rahul that I am sending from 1, so that if anything is missing, you should know. And similarly, Rahul is going to say, Anjali, I want to talk to you. My sequence number is 0, length is 0. This is the synchronous message. Anjali is going to say acknowledgement 1. Now at this point, both knows. Anjali know that Rahul will be sending me message from sequence number 1. And Rahul is there because he has replied. And Rahul is also absolutely sure that Anjali is there and she is going to send me the packet with sequence number 1, whatever the data packet. And this is what we wanted. And this exactly is your connection, guys. Right? We will show you this thing on the Wireshark. Now the question arises, an interesting question. Mr. Vishnu, whatever you have taught us, this is 4-way handshake because we have 4 packets. I have never ever read that 4-way handshake. Guys, we are building our knowledge. So I thought this way is going to be interesting to tell you, right? But now somebody like you told me that we can improve this process, right? At the end of the day, what we are doing here is we are sending a message, right? This one, and what we are sending, and by the way, there are 2 things. One is acknowledgement number, which is 32-bit long, right? Another is acknowledgement flag. Just like SYN flag, we have acknowledgement flag also, which flags that this is acknowledgement message, right? So what we are doing in this message, we are sending an acknowledgement. This is my acknowledgement, and in this acknowledgement I have set acknowledgement is equal to 1. It means that it is a flag, and now I am acknowledgement number value is also 1 here, right? If maybe we have 520 here as a sequence, then acknowledgement number value will be 521. As simple as that, right? Now the question is, what we are sending here, we are sending in this packet only acknowledgement. Can't we send in the same message, this is the message sequence number 0, it is going to have length 0, and this is also the SYN message, so we can combine these 2 messages into 1, and that is why we have reached to TCP 3-way handshake, right? We are sending sequence 0, length 0, SYN 1, right? Maybe Rahul could have sent only acknowledgement, but people like you would say, no, make this process efficient. So what we are sending acknowledgement 1, but along with that, in the same packet, because we have ampli field going, we are saying this is the synchronous from Rahul. This is having length 0, this is sequence 0, and Anjali is going to acknowledge that. If these 3 messages have been exchanged, then the initial connection is formed, and if the initial connection is formed, we are good to go to send data, right? And I would like to showcase you this on Wireshark. But before that, I can see that there are some hand raise. Mr. Vipul has a hand raise. Mr. Vipul, you can ask your question. Please go ahead. Mr. Syed, you can ask your question. Guys, you can raise your hand. Please ask your questions. Now, this is interesting. Let me take you to this board so that we can get it. So what is happening here is we have source and we have destination, we have Anjali and we have Rahul. So what's going on here? Anjali want to send 1 packet or some data, the same thing, I don't love you. But before sending, she want to make a connection. Connection means just sending of some messages, initial messages. And when we send initial messages, there is no data in it. If there is no data, it means that we are sending just the header information, right? Although this is data, but that is not actual data which is going on. So what I am writing here is that my sequence number is 0, right? and this is my SYN packet. Achha, what is this SYN? This SYN is not number, this is the flag. Okay, if this is the flag, then this can be 1 or this can be 0. I am saying the SYN flag here is 1. The meaning is whatever the message I am sending, when Rahul receives it, it should immediately see, oh, SYN is set. So there it means that basically this is a synchronous message. Anjali want to tell me something. So what Rahul is getting from this? Anjali want to start her communication from sequence. The sequence number of this packet is 0. And TCP at Rahul understand this as, see, at the end of the day, who has developed TCP? Not God. We, the person like us, have developed this TCP. So it is up to them what they want to think about from it, right? So they are saying if the sequence number 0 is coming, what I can say, means Rahul is going to say, Rahul is saying that, okay, I get your point, right? This is my acknowledgement message and I am sending it what? Acknowledgement 1 means that this is the flag, right? Whatever the information I am sending you, this is acknowledgement. But inside this acknowledgement, right, we have acknowledgement number also. See, these two things are different, flag and number. And in this number, I am also saying that 1. What is the meaning? This is not the flag. This is actual number 1. It means that the receiver is saying, I understand, Anjali. I got your packet. I got your message, SYN message. Now, if you want to send me data, you can send me your data with sequence number 1. As simple as that. This is the normal understanding. Now, suppose Rahul is now one-way communication is done. Now Rahul wants to communicate to Anjali. Rahul is saying, here is my SYN message, which is 1. Synchronous flag is 1. This is the SYN message. And maybe it can start with any sequence number. Suppose it is starting with sequence number 5, right? Now the common, this term is Anjali's TCP is what Anjali's TCP will understand. That I got the message, initial message from Rahul, right? I want to reply that I got your message and I want to tell him that you can send with sequence number 6. Why 6? Because this is the common understanding. How people explain this, people say that basically what we have said, that sequence number plus length field is going to give you next packet sequence number, right? But if you add 0 plus 0, it is going to be. So they say that there is a ghost byte, right? Which we can't see. But to make this communication, it happens. But at the end of the day, this is developed by guys like us, right? So it is just overall try to see, don't go into these numbers. Just try to understand what we are trying to achieve. We are just trying to achieve that Anjali should understand that what should be the first packet number of Rahul which he is going to send, and Rahul should understand what should be the packet number of what should the first data packet which Anjali is going to send, and it is going, and after this they will come to know that Rahul come to know that Anjali will be sending data from packet number 1, and Anjali will come to know that Rahul will be sending the data or the segment which is having sequence number 6. Again, I'm saying SYN is purely a flag which can be having 1 or 0 value. Okay. Acknowledgement are two things. One is can having 1 or 0 value means it is a flag also. It's a number also. When I say that acknowledgement 501, it means that I have received data till 500 and I am expecting you to send data from 501 segment sequence number. Perfect. Mr. Himanshu Paniaji, please ask your question. Mr. Himanshu. Okay, so let me explain you this, then we will get to know, right? So TCP also comes with the concept of ports. Now, actually we were talking about only what? Sequence number, acknowledgement, SYN, and ACK. What we are talking about this one, what most interesting thing is it's port number concept. So how I explain it, suppose we want to send a letter to this home, right? And this home is having maybe 3 or 4 people living here. This home address is say 312, maybe in Bangalore somewhere. What I do is I write a letter, I write 312 on top of it, right? and then basically I say it should go to Bangalore and so many things, and so whatever the things are, this letter will be reaching here, and then basically inside this home there are 4 or 5 people. If that is the case, what is going to happen, right? We have to mention the name also. Similarly, a computer basically is on computer there are many applications like WhatsApp is running, maybe a web server is running, and so many things, right? If this packet reaches here, IP packet reaches here, so this guy is having IP address of suppose 2.2.2.2. It is coming from x.x.x and going to 2.2.2.2. Now the question arises, once it reaches to this IP address or this address, right, to which application we have to give it? And that is where the concept of port comes. So every application is having a port number. So for example, the web application is having 80, or maybe the SSL which is listening at 443, right? Now I would like to take you an example where two routers are working, right? We have router number 1. Now I am coming to a 4-way handshake. Now router number 2. We are running BGP on it. So BGP, actually what is the use of BGP? You all know. At the end of the day, it is going to exchange what? Routes from here to here. And we do not want that any route should be lost somewhere in this middle, right? So we need to use a protocol which is highly reliable, and we are using TCP here. So once we run TCP, basically this will start listening at protocol port number 179. This will also start listening at port number 179. So what is going to happen first? If we want to send a route, we want to send it over TCP so that it cannot be lost. If I send it over UDP or IP alone, it can be lost, right? OSPF has its own protocol so that the routes cannot be lost. If you see OSPF, there are mechanisms there so that these routing information cannot be lost. But BGP will say that I do not create any new protocol. I will be using this TCP only. So when you run BGP on R1 and R2, they will start listening on 179. And suppose the communication started by R1. R1 will going to say send. For this send message, it is going to start, right? It is going to write the source port. Source port is, it is going to choose anything, right? Any large number. Let's 32756, suppose, right? This is going to be my source port. The destination port, we know that we want to make a communication with BGP, so it is going to be 179. This is the port number, right? So what we are creating here, there is a send message of TCP so that initial handshake can happen. So this is going to be the initial send message. When R2 receive it, what R2 is going to say that okay, that is perfectly fine. Now the destination port is going to be 32756 and source port is going to be 179. And then this is going to be my send plus ACK, and then ACK message. Once connection is made, your TCP is up, BGP is up, and then you start sharing your route, right? Now the question arises with respect to your 4-way handshake. Now you have configured BGP at both the end. If this R1 is initializing the conversation, it is going to connect on 179. Suppose R2 has initiated the connection, then basically the source port it is going to use means any ephemeral port. Ephemeral means any number, big number, and the destination is going to be 179, right? What is going to happen if R1 and R2 both start communicating at start communication at one point, right? It can happen. If that is the case, then basically we result into 4-way handshake, which is exactly the same whatever I was talking about. But I would highly recommend to see that course which I have given you with this course, TCP1. Please do have a look, right? Because those 12 hours of information, if I want to converge in just 1.5 hours, it is not going to make sense. Okay, am I making any sense? So Mr. Godwin, I'll take your question later. So sorry for that. Let me complete. And it's interesting that I am getting first time more question in English class than Hindi class. Right? This is amazing. So now let's see whatever we have just studied till now. This I will be talking about data transfer in tomorrow's class. I will be showcasing everything. Basically, I am ready to showcase everything today itself, everything was ready on the Wireshark, but I highly doubt that we can do it. So now just give me 5 more minutes so that I can finish it. Okay. So I have a communication and I have marked the packet also. Whatever you are seeing in this yellow color, this is my TCP three-way handshake, right? So I have two computers. One is this computer and another one is server. The server address is 217.21, 19.11, and then basically we have 192.168.1.50. This is my PC, right? And I want to send something over TCP. So before sending the data, I cannot just send the data as it is, because if I send it, it is going to be a problem. I need some thinker who can control everything, right? So who can tell me that whether there is anybody on the remote end, and if it is, then basically we need to synchronize with it, and then I can send the data, right? So this is what happening. This is my source, this is my destination. So if I show you the transmission control protocol packet from here, the source port is this one. This is my ephemeral port I was talking about, the big number, right? Any random port. And the destination port is 443. 443, if you have came across this HTTPS, this is secure socket layer, or TLS, transport layer security, which we are going to talk about tomorrow. We are making a communication, right, with source port this and destination port this. Right now the length of the packet is 0. Why the length is 0? Because this is just the SYN packet, synchronous packet. I'm not sending any data, right? And my sequence number is also 0. And this is my relative sequence number. If you want to know exact sequence number which TCP has come across, this is this one, the big number, right? And that is what Wireshark is your friend, guys. It is saying that instead of having this number, why I can't assume this number as 0, so that the calculation becomes easy for you, right? So the first packet, it is going to say sequence number is 0. This is my relative sequence number. Actual sequence number is this one, right? But you can do all the calculation from sequence number 0. Now the acknowledgement number is also 0 here, right? This is acknowledgement number. Okay. Now because anyhow this is not this is not any acknowledgement, nothing like acknowledgement is here, right? And now the next sequence number, as I mentioned, this is the setting between the TCPs, that basically if we are sending sequence number 0, I expect, right, that I will be sending the next sequence number as 1. Okay. Although I'm not sending any data is length 0. Now if you see the flags here, definitely SYN is set. If you count 1 2 3 4 5 6 7 8 9 10, 11th bit is set, and 11th bit is your SYN. Although there are many other flags like fin, reset, push, acknowledge, so many things I have explained in that 12 hours class. Believe me, just have a look at it and you will be good. So this is my initial synchronous message, right? If I talk about SYN ACK from the server side, again, now the port number are going to be reverse. Source port is this, destination port is this, right? As simple as that. And now if I talk about the TCP length, again 0 because there is no data, sequence number 0 because it is coming from the Rahul side or the server side, right? Relative sequence number, see, these can be two different things, as I was talking about, that Anjali can say I am sending packet number 0, right, length 0, and then Rahul can say that I can start from 526. But Wireshark is your friend. It is going to say that this number I am assuming 0, I will be counting starting from 0. For that you just need to see this number, sequence number 0, acknowledgement number 1. And then here basically you see the two flags, SYN, because it is coming from the server synchronous message, and then we have here acknowledgement set also, right? Last message is going to be, which is very important and the crucial last message, is basically is saying your connection is getting complete. If we see the again, it is from the client towards server 443. Sequence number is 1 of this packet, absolutely, although it is not taking any data, but the sequence number for this is 1, right? And acknowledgement number is also going to be 1, because previously we have sent acknowledgement 1 because sorry, the sequence number is 0, acknowledgement 1, because we are acknowledging the server packet now, right? And then here acknowledgement is set. So SYN ACK, and then ACK again. Now initial messages are done. Believe me, now this is just the start. What I did in today's class, I have just squeezed my 2 hour and 50-minute session into this 1 hour and 20-minute kind of session, right? But if you just have a look at the class, it is going to give you amazing thing, because tomorrow we will be trying to understand, to see all these things, to understand the data transfer also, right? In the whatever from whatever we have just learned. Believe me, you just need to understand only addition, and you just need to understand only today's class. That is more than enough. Now, considering the slowness and other things, those are important, but those are going to be over your head if you don't go in these concepts. So I will take the slowness issue maybe in the last class. Tomorrow we will be talking about SSL, and we'll see the data transfer in actual Wireshark. Till then, this is what I had in my mind before I started this class. Now, to you, whatever you can, whatever question you have in your mind, until unless I give the answer, I am not going anywhere. Yes, you can say, but anyhow, Prantik, you just try to understand that we need to start from somewhere, right? Right? This sequence number can be any number, but suppose this is another interesting question. Believe me. Okay, so Mr. Prantik, what did you say? Suppose if I want to send this message, suppose the length is also 0, no data in this, there is no doubt, but I still need to send it, right? If then I can choose any started number. Generally Wireshark say that the relative number is sequence 0, but this number can be 526 also. This is just the start for me. Now if basically this is the SYN message I am sending, and now the server is going to say that see the starting point, again the connection meaning was server should understand what should be the packet you are sending with which sequence number. And now server is saying that okay, I get your sequence number 526, I acknowledge that I receive 526, whatever the data you want to send me, send it from 527. Now when data goes, right, is first byte is going to be 527, then 528, then 930. Suppose the 4 bytes were going, the last is going to be 5530. Am I making myself clear, Prantik? Yes, but in Wireshark there is an option that you can see the relative. Whatever the big number it is generating, it is going to say let's start from 0, so that the calculation can be easy. Yeah, I got your question, and it's a very, very interesting question, right? So, see, dividing the protocol into something that whether it's working at layer 2, layer 3, it is totally hypothetical and depends on person to person, right? What is my understanding? Just try to understand. At the end of the day, what BGP is actually doing? BGP is just sharing routes, right? Which is network layer reachability information. And mostly the routes we define on the network layer. So to me, still BGP is still a network layer protocol. But here, one thing is that we want to exchange these routes, router 1 and router 2, in a reliable fashion. So BGP so that is why I define protocol from its functionality, not what exactly it is doing to share the route. Exactly the functionality is sharing the network, sharing the routes. That is why basically it's a layer 3 protocol. But if you say most of the time the interviewer sometimes is trying to say, right, or they try to confuse you that but it is using TCP is a layer 4 protocol, right? Then why basically it's not layer 4? So the answer is simple, right? If I say it is just the perception, I presume that BGP is there to share the route, that is why it is a layer 3 protocol. But yes, to share those route it is using this TCP, and if you want to categorize in layer 4, I do not have any problem with it. But still, to me, a routing protocol should be defined from the perspective of what exactly it is doing. It is sharing route, it's a layer 3 protocol. Okay. But amazing question. Thank you so much. Now, Mr. I would say Mr. Syed, please go ahead and ask your question. See, we are getting the stream of ones and zeros from top, right? There are multiple algorithms that on the basis of which the TCP decide how much is going to be the segment size to send it efficient, right? Different approaches, different ways, but those are internals to TCP. I don't think I don't have any idea about it, that how it is going to sequence. But yes, windowing plays a crucial role in knowing that how much uh, how much data can be there at the receiver window. So for that means I would highly recommend you, Mr. that you just have a look at my flow control 1 or 2 hour session on that, and it is amazing. You would love it, right? But these internals, how basically TCP is taking that stream of data and coming on the conclusion of how many how it is going to segment. Those are basically some algorithm which I do not have idea. Not end to end, hop by hop communication happen on the basis of layer 2. I got it. No, this is something which is very crucial. Just try to understand. So suppose R1 gets this packet, right? 1.1.1.1, and which is going towards 2.2.2.2, right? So of course, it will be getting this packet here with some source MAC and destination MAC also, right? And of course, this destination MAC going to be this one, and that is why this router key can read IP, router can read MAC. Okay, when this complete frame is received on router, suppose 0/1 interface, router is going to check what is the destination MAC address. If the destination MAC address matches with the 0/1, it is going to open it. It is going to open it, which is very, very important. If we call it as a switch, then switch doesn't have this capability. It is going to see only the destination MAC and then forward it. Now, to your question, when it open it, it is going to see the destination is 2.t. It doesn't matter, right? Because it has just decapsulate, right? Decapsulate. This thing is gone, totally gone. Now this router is having this IP packet, and now router is going to see the destination IP address, and now this is going to see its routing table. Where is 2.2.2.2? Suppose there are two paths, maybe R4 is there, right? It is going to see in the route that if you want to reach to 2.2.2.2, you need to reach via, maybe this address is say maybe this address, whatever you have configured, maybe 192.168.1.1 here, and it is 1.2, right? It is written that if you want to reach to 2.2.2.2, you should go to 192.168.8.1.2. This is your next hop, right? Before sending this IP, now this router, after discussion with the routing table, now it knows that it needs to go to 1.2, not 1.3 or 1.5, right? It is going to do an ARP here so that it can get the reply back of the ARP message. Now this message, which was your 1.1.1.1, which was going towards 2.2.2.2, it is going to be encapsulated in another layer 2, which is going to be having the MAC address of this interface, source MAC, and the destination MAC of this. But do you get my point? Okay, perfect. Perfect, no worries. So now Mr. Vipul, you can ask your question. But guys, raising hand is fine, but just adjacent to raising hand, there is a reaction button also. If you really like the class, just give me thumbs up, just do a clap, because I am just sitting in front of a monitor, right? I do not know what is going on in your mind. So if you are liking it, and this is what motivates me to create some good content for you, right? And thank you so much for your lovely emojis. Whatever is coming, Mr. Isa Deara, please ask your question. Thank you so much for your lovely emojis. Yeah. Isa, just unmute yourself and ask your question, please. Okay, anybody unmute yourself and ask your question if you have anything. If no, then thank you so much for being a wonderful audience, and thank you so much for asking such a great question. And I would say, well, it is happening first time that in English class I am getting way more question than Hindi. It's all about.
I hope that you have enjoyed the video. In the next video, we are going to talk about MSS and MTU. And believe me, MSS and MTU is one of the most frequently asked question in most of the networking interviews, right? And this is also a pain for many network engineers. So see you in the next video.